In this video, we are going to be looking at differentiating rational powers. In our previous video, we looked at differentiating negative powers. So rational powers are essentially surds or powers with fractions as the power. Here are the examples that I will go through in this video. So you can pause this to write down all the questions, or if you would like to attempt these first, definitely go ahead. I'll jump in and dive right into the first one. Now, differentiating this, I might write the extra steps in between. But essentially, what we want is the power to be expressed as a fraction before we go to find the derivative. In this case here, we take the power, we multiply it at the front, and then we subtract the power by 1. But subtracting the power by 1 is the same as subtracting by whatever that whole denominator is. So I'll just say every time when I look at this, I look at the denominator and I will subtract the value of the numerator with that denominator. So essentially, I'm only going to write this down for the first example here. But we end up with x to the power of 1 over 4. Moving forward, I will just jump straight to this, and 5 over 4 minus 4 over 4. I'll just read this out when I do the calculation. Let's go to part B. We can see that this is currently expressed as a surd form. And essentially there's a power of 1. And if you do not see a root number on the outside of that surd, the base value is always a 2. So what I'm going to do is I'm going to rewrite this g of x here as 3 times x to the power of 1 over 2. Now it's in a suitable form for us to differentiate g of x or find the derivative. So it's going to be called g dash x. Take the power, we're going to multiply it at the front, and we're going to subtract the power by 2 over 2, which gives us negative a half. Now I'm going to go the extra mile here, and it's going to be an extra 2 steps, I believe. But this x to the power of negative a half, if I want to re-express this as a positive index, I'm going to bring it down into the denominator with 2. And if I want to make it even easier to substitute and express myself, that x to the power of a half is the same as the square root of x. So I can see that there. In the other questions, I will do my best to express it in that particular form. Now, in this part C example, you can see that the powers are already a negative power, like such, or it's already expressed in a rational power. So we can go directly to finding the derivative, which is expressed as dy dx. So we're going to take the power, multiply it at the front, and subtract the power by 5 over 5. So we end up with negative 4 over 5. Going to differentiate this term now, so take the power, multiply it at the front, and subtract the power by 1. To express this as a positive index, it's going to be expressed as, oops, oh, I think I might write this a bit neater. X to the power of 4 over 5 in the denominator, because we make it jump the line or jump the vinculum. Likewise with the next term, it's going to be expressed as such. One more line to make this super easy if we ever want to substitute a number in. The denominator becomes the root value, and the numerator is the power that is raised outside. So if we ever substitute in an x value, it becomes more simple to evaluate this. However, if you do have your form as such, then that is completely okay. So this here is correct. If you do want to take the extra step at your own risk, then you can take the last step there. Okay. In this example here, what I notice is that this is a surd. And so what I'd like to do is re-express this as a fractional indice as our first step. We also have a bracket here as well. So what I'm going to do is expand this 5 x to the power of a half into both of these terms. So what's going to happen is we are going to end up with 5x. Now, x to the power of a half times x to the power of 2, we need to add these powers. So this is the same as 4 over 2. 1/2 plus 4 over 2 is 5 over 2. I'm going to expand the second term here. 5 times negative 2 is negative 10. And we end up with x to the power of 1/2. Now this is in a suitable form for us to find the derivative. So this is going to be expressed as h dash x. We take the power, multiply it at the front. We end up with 25 over 4. Oh, 25 over 2. And then we subtract the power by 1, which is 2 over 2. 5 over 2 minus 2 over 2 is 3 over 2. Take the power for the second term. Take the power, multiply it at the front. Negative 10 times a half is negative 5. We have the half. We subtract that power by 1, which is a half minus 2 over 2, which becomes negative 1 over 2. We can just re-express this here as positive indices. So this x to the power of a half here, negative a half, jumps the line and it goes into the denominator. And the final step, and this is optional, you may stop here if you wish. The final step, which makes it easier for us to evaluate, is to change everything into surd form. So this 2 here becomes a square root of the x, and the power of 3 in the numerator is raised on the outside. X to the power of a half is expressed as a square root of x. I'm going to do these examples now, but speak less, and I'll focus more on speed. 2/3 times 4 is 8/3. Subtract the power by 3/3. We can differentiate this one directly or immediately. Negative 2/3 times 12, that's negative 24/3, that's negative 8. Subtract the power by 1, which brings us to negative 5/3. Take the power, multiply it at the front. 9 times 7/3, the 3 and the 9 cancels out. We end up with negative 21. So with those little calculations there, don't hesitate to write them on the side. Do that calculation and you can always put it back in. Oops. Last, I'm going to change this back into surd form. Just in case if you ever need to evaluate it by substituting in a number. But this form here is acceptable. In this one here, we see a surd. We need to express it as a rational power. So we're going to keep f of x, but express this as x to the power of a half. Now, we can also simplify this. If we're multiplying by the same base, which is x, then we can add the powers. So in this particular example here, it's an exercise of simplifying your equation first before you find the derivative. But once you find the derivative, it should be absolutely fine. I'm just taking this extra step here. Just in case if you need to substitute. Last but not least, we've got the operator notation. Now, in this case here, notice I'm not differentiating yet because I want to simplify this. I'm going to re-express this as x to the power of a half first. I haven't differentiated yet, so I still need to write the d dx out at the front. Now I'm splitting up the fraction. And I am now going to subtract the powers. So this is the same as x to the power of 1 minus a half, plus, for this one here, I'm going to take x to the power of a half from the denominator to the numerator. So it becomes an acceptable form for us to differentiate. Now obviously you can write some of these steps, you can leave some of these steps out if you do the calculations in your head, but again, do this at your own risk if you want to skip steps. So now we're going to find the derivative. Because it's an operator notation, our next line is just going to become an equal sign, and we start differentiating. Negative a half times 2 becomes negative 1, negative 1x, you can leave your answer like this, but again, just in case if you need to substitute an x value in, the denominator of 2 is the square root of x, and then you've got raising everything to the power of 3. That's it. So these are all the examples done in this video. Did take a bit of time, but now you can see how to differentiate by rational powers. Don't forget to pause the video, rewind and rewatch if you'd like to revise. Thanks for watching.